All right, this is Geometry, Chapter 5 review. I'm going to begin walking through the lessons, all right? So in lesson 1, on page 185, we talked about the properties, addition, subtraction, multiplication, division, right? And I want to draw your attention to two particular property, well, three. We're going to do three. We're going to compare transitive to substitution so we can make sure we understand the difference. Transitive would be something like AC greater than DE, DE greater than FG. Therefore, we could say AC greater than FG. So transitive is always 1 greater than 2, 2 greater than 3. Therefore, the first one is greater than the third one, or it can be less than. Substitution would look like AB plus 10 is equal to CD, and CD greater than EF. Therefore, AB plus 10 greater than EF. I substituted in for CD, AB plus 10. All right, then let's look at the addition theorem. Of inequality. As opposed to just simple addition. All right? And how do they compare? With the addition theorem, we may have, let's do AB greater than CD and EF greater than GH. Then I could add the 2 on the left, AB plus EF, and say that they are greater than the sum of the 2 on the right, CD plus GH. Whereas if it's simple addition, I may just begin with AB greater than CD. And addition would be I add the same amount on both sides. So I may say AB plus EF is greater than CD plus EF. Do you see the difference? Make sense? And then I want to compare. Can I erase this? I want to erase. Then I want to compare. Let's do it with an angle. It's time to start throwing away, huh? Say it again.
Class is over.
No. It's time for me to start throwing away markers.
Oh.
Got it?
It says time to go.
No. All right. A, B, C. We'll call that angle 1 and angle 2. All right. Now the whole greater than part would say the whole angle ABC, the whole angle ABC is greater than angle 1, part of the angle, or we could say the whole angle ABC is greater than angle 2, the part. That is different from betweenness of rays. Betweenness of rays says angle 1 plus angle 2 equals angle ABC. However, I can go from betweenness of rays to whole greater than a part. So if I write betweenness of rays, then I could say any part of that angle is going to be less than the whole angle. So if I can write betweenness of rays, and that is given, then what can I know? I can know that ABC is greater than 2 and ABC is greater than 1. So I can go from betweenness of rays or betweenness of points, right, to go to whole greater than part. Got it? So if I can write betweenness of rays or betweenness of points, then I can know that the entire length or the entire angle is greater than any part of it. All right? And for this lesson, you should absolutely look back at problems 7 through 12 on page 186. It's statements, and you have to write the reasons. Any questions from lesson 1? All right, lesson 2. I would also make sure I know how to work the proofs from lesson 1. 45 through 48, numbers 45 through 48. Just go back and review that. All right, lesson 2 was the exterior angle theorem. There are 2 statements that we can write about an exterior angle. Well, let's write everything we know about an exterior angle. What do you know about an exterior angle?
They're greater than the remote interior.
Okay, so I can write angle 1 is greater than what angle? No, I cannot write angle 1 is greater than 2. But I can write angle 1 is greater than angle 3. I can write angle 1 is greater than angle 4. Is there anything else I can write?
Angle 1 and angle 2 make a linear pair.
Okay, I can write angle 1 plus angle 2 equals 180 degrees. Why? Because an exterior angle forms a linear pair with an interior angle. The interior angles are on the inside of the triangle. The interior angles are 2, 3, and 4. There's something else I can write with an exterior angle, an equation.
Angle 3 plus angle 4 equals.
I'm going to write angle 1 equals something.
Angle
the measure of angle 3 plus the measure of angle 4. So when I'm dealing with exterior angles, I know that an exterior angle is greater than either remote interior angle, and it is equal to the sum of them. There are lots of images on your test where you have to solve for the measures of angles. Let's just label. Okay, 4, 6, 8, 9, 10, 11, 12. All right, what are the interior angles? List all the interior angles. Go ahead, Ben. 3, 4, and 2. All right, list the exterior angles, Hannah. Just exterior.
1,
1,
12,
12,
10,
10.
9,
Yep.
and 7, and 6.
Yes, all of those are exterior angles. Ella, what are 11, 5, and 8? They are some relation to the interior angles. Blythe? They're vertical to the interior angles. So 2 plus 3 plus 4 has to equal how many degrees? 2 plus 3 plus 4, the interior angles have to equal 180 degrees. So what must 5 plus 11 plus 8 equal? 180. What must 10 plus 1 plus 7 equal? 10 plus 1 plus 7. 360. Why? Because when we go around the exterior angles on the same side, does it matter how many sides I have?
No.
It does not matter. I don't know how many sides I can make, but let's just see how many sides I can make. I'm gonna close this. Okay, I can't go out any further. Okay, but 1, 2, 3, 4, and 5. The sum of those, and 6. I missed one. Going around, the exterior angles on the same side, the sum is always 360. What? We'll label these with letters. A, B, C, D, E, F. What would the sum of A, B, C, D, E, F be? All right, I gave you a pattern, I believe. All right, a triangle has 3 sides. What's the sum of the angles? 180. The sum is 100 of the interior angles. I'm talking interior. All right, a quadrilateral. What's the sum of the interior angles? A pentagon.
540.
You keep adding 180. It's 540. All right. 1, 2, 3, 4, 5, 6. What's the sum of the angles?
720.
You add 180 every time. You keep adding 180. All right, so this has 6, so it's 720. What if let's label it X and Y. What if we had this? Could we figure that out? How? What do you think, Madeline? Let's start with x. That's where I would start with. How would we solve for x? X is interior. How many sides does that polygon have? 4. So what would be the sum of all the angles? 360. So how do I solve for x?
Wait, is that a 10?
150, 60, 50, x.
100. It's X.
It would be 100 because you would take 360 minus 50 minus 60 minus 150. That's 260. So x would equal 100 degrees. Then could we get y? Yes. What's y, Nepheli?
80.
80 because it is
A
a
linear pair.
linear pair, right? All right, exterior angles. I would know how to work 26 through 30 from this lesson. 26 to 30. All right? Now, lesson 3. Triangle side and inequalities. Does anybody remember what that lesson was about? Triangle side and angle inequalities. Lewis, what was that one about? Triangle side and angle inequalities.
So is that one of the ones with like the opposite sides unequal angles?
Yes, exactly. All right, so if I said this is 10, 6, and 12. Those sides are 10, 6, and 12. Then I could write some inequalities, right? I could write AC is greater than BC. Do you agree? Side AC is greater than BC, clearly. It's twice the size. From this, I can write an angle inequality. I can say the angles opposite these sides are unequal in the same order. Keywords, in the same order. So opposite AC is angle B. Opposite BC is angle A. So if this is given, this is what I can know. I could order the angles in largest to smallest. The largest angle would be angle B. Angle B would be greater than, what's the next angle? Greater than angle C, which is greater than angle A. So I can know those inequalities. All right? By the same token, if I have unequal angles, which if I have, what kind of triangle is this?
Scalene.
What kind of triangle is this? Scalene. Both are scalene, right? Then I could say that angle D is greater than angle F. If I know that angles are unequal, then I can know the sides opposite them are unequal in the same order. So opposite angle D would be side EF. Opposite angle F would be side ED. So if that is given, this is what I can know. Why? Because sides, opposite unequal angles, are unequal in the same order. And from this lesson, I would make sure you can look and work problems 4 through 20 and 45 through 49. All right, lesson 4. Sort of a similar name, but a different concept. This is the triangle inequality theorem. We'll use this first triangle. What does the triangle inequality theorem say, Locke?
The sum of any two sides of a triangle is greater than the third side.
Correct. The sum of any two sides of a triangle is greater than the third side. So, that side plus that side has to be greater than the third side. That side plus this side has to be greater than the third side. This side plus this side has to be greater than the third side. The sum of any two sides of a triangle has to be greater than the third. And let's suppose we don't know the side. We can calculate what the possible range of that side would be. So every place that I'll just erase this. Every place that I have a 6, I'm going to replace with an X. And one statement is not going to make sense, okay? Because we don't have negative signs. All right, so 12 plus X greater than 10. X plus 10 greater than 12. 10 plus 12 greater than X. This last statement makes sense. So 22 greater than X. This one's not going to make sense when I subtract 12. I'm going to have a negative number. That one's not going to make sense. You ignore it. Here you subtract 10 on both sides, and you have X greater than 2. So 2 less than X less than 22. X has to be between those numbers, between 2 and 22. You have to be able to write an inequality and solve for the inequality, for the range of possible lengths of the third side. For this lesson, I would look back over problems 10 through 31. Problems 10 through 31. All right, here's some things you can't do. You can't say an exterior angle is greater than the interior angle it's a linear pair with. You cannot say that. Don't write that on the test. You cannot say an exterior angle is greater than the interior angle it makes a linear pair with. Don't write it. Most of your exterior angles are obtuse. Most of them. That is not absolutely necessary, because if you have an obtuse triangle, then one of them is going to be acute. In an equilateral triangle, what's equal? In an equilateral triangle, what is equal? In an equilateral triangle, all you could say is all sides are equal. Then you could say equilateral is equiangular, right? When you have two equal angles, what kind of triangle do we call that? Scalene. And when we have isosceles. Correction, isosceles. Yes, they were saying isosceles and scalene came out of my mouth. Yes, two sides equal isosceles. No sides equal scalene. Or you understand transitive. 1 greater than 2, 2 greater than 3, therefore 1 greater than 3. Can vertical angles never be equal? They are always equal, right? Okay, this is what we're going to do after we take a short break. We're going to look at the review. Here's the problems we're going to work. We're going to work 15 through 25. This is what I would focus on for the test. 15 through 25. 41 to 46. Actually, I just have all 41 through 50. I don't know why I broke that in 3 parts, but 15 to 25, 41 to 50.